Hello friends, welcome back. Let's solve a longest common subsequence problem using DP. Two strings will be given and you have to find out a common sequence in the both the strings. So here in this case B is present here, B is present here, G is present in these two strings, P is present in these two strings and J. Okay, it need not be sequential. Okay, so BGPJ is the longest common subsequence and we just return 4 as a output. Okay, we just written the length of the longest common subsequence. So we have to evaluate two choices. So the option 1 is, so whenever you are given with two strings, string 1, okay, when the two strings are equal, when the last two letters are equal, so one letter is there in the longest common subsequence, so you just add 1 plus, and now you try to find what is the longest common subsequence in the substring. Okay, so these two letters are there in the longest common subsequence, so we just added 1. Okay, these two letters are included in the answer, 1 plus. Now we try to find what is the longest common subsequence in the substring. 1 plus longest common subsequence of the substring, ignoring the last letter in both the strings. Okay, option 2, when the two letters are not equal. So in this case we consider ignoring the last two letters individually. So for example, I try to find the longest common subsequence ignoring the A. Okay, so this string is considered and till here this substring is considered. I will try to find the longest common subsequence with this combination and I try to ignore this letter K. Okay, I try to ignore K and with that combination I try to find a longest common subsequence with this substring. Okay, with this substring and this whole string is considered. Okay, with these two things, okay, I calculate the longest common subsequence individually and I take the maximum. What is the maximum output in these two LCS? I take that particular longest common subsequence. Okay, let me repeat again. So when the two letters are not equal, okay, just close the K. Okay, just close the K and try to consider this substring comma this entire string, and now try to find the longest common subsequence. Okay, you will get one answer. Now try to ignore A in the second string, last character in the second string, and you try to find the longest common subsequence for this entire string until here. Okay, you will get one answer. So out of these two I will pick up the maximum. So these are the cases. So evaluating the cases in the dynamic programming comes by practice. So we have to practice n number of problems. Okay, now let's write the recursive function. We have evaluated the choices. Now let's write the recursive function with base cases. String 1 is equal to, okay, let's add this string, and string str2 is equal to, let's add this string. Okay, now LCS, longest common subsequence, and we just need to add two varying parameters, s1 length and int s2 length. That's it. Okay, so what are the, okay, if the last character str1 of s1 len minus 1 equal to str2 of s2 len minus 1, if both are equal, then just return 1 plus LCS of s1 len minus 1 comma s2 len minus 1. So you have to find the LCS of the remaining substring. Else int option 1 is find LCS of Okay, you just reduce the, if last two characters are not equal, okay, you just find the LCS of s1 len minus 1 comma s2 len. Okay, you just remove the last character in the first string and you will take the entire second string as is, and in the option 2 LCS of, okay, you consider the entire s1 length and you just remove the last character in the s2. So either of these two options you take the maximum, you consider the maximum, right? Okay, the option is find the longest common subsequence, which is, so we have to find something which is longest, means maximum. So we have to consider max as an option. Okay, so A greater than B, ternary operator A and B. Okay, you have to include the brackets for all this. Okay, now so it will return the maximum of option 1 and option 2. Now we have to add the base cases. If either of the s1 length is equal to 0, or if s2 length, if either of the string length is 0 and other string remains, then nothing is there. So for example, if this string is 0, okay, s1 is 0 and s2 is some string, so what is the longest common subsequence in between these two strings? Nothing. 0 is the answer, right? So there is no string here and there is some string here, there is no common in between these two strings, so 0 is the answer. So if s1 is equal to 0 or s2 len is equal to 0, we have to return 0 as the answer. So let's find LCS, cout LCS of str1 dot length comma str2 dot length. Let's find the answer. Okay, the answer is 4. Okay, so the answer is 4. So what do we know? If we try to increase the length of the string, okay, if we try to increase the length of the string, we will get stack overflow. No, if we try to increase the length of the string, we won't get the answer. Okay, because of overlapping subproblems, it keeps on trying to solve the same thing again and again. See, we are not able to get the answer. Okay, so for this purpose we have to use caching technique. Int cache, so I will mention in the question the string length won't be greater than 150. So cache of 151 of 151, because two varying parameters, s1 length and s2 length, two are varying parameters. So set up the cache, init cache, okay, for int I is equal to 0, I less than 151 I plus plus, for int j is equal to 0, j less than 151 j plus plus, cache of I of j is equal to minus 1. So we initted the cache. Let's call the cache in the main, init cache. Okay, so we store the result in the cache here. So for a particular s1 length, for a particular s1 length and s2 length state, we are storing the answer in the cache. Okay, and in the base condition, for a particular s1 length and s2 length, if in the cache, if the answer is not equal to minus 1, we are returning that answer. This will avoid further recursion. Okay, so because of this we are reducing the recursion, so we'll get the answer very quickly. See, the answer is 28. 28 is the answer. Okay, so length of the longest common subsequence is 28. Okay, fine. See you in the next video. Bye.